Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss about gas equilibrium constant Kp part 2. The decomposition reaction of PCl5 proceeds to produce two products. The reaction vessel with a volume of 2 liter initially contains 2.5 atm of PCl5. Experimental analysis indicates that the partial pressure of chlorine gas at equilibrium is 0.70 atm. Determine the equilibrium constant Kp for this reaction. Alright, so the first thing that we need to do for this question is we need to find what is the balance equation for this decomposition reaction. So given to you is the decomposition of PCl5. So it will decompose into two products. One of the product will be chlorine gas, so Cl2, and then the other product. So what is it? So you are left with PCl3 because you have a total of 5 chlorine, and then now you have chlorine gas Cl2, so you need another 3 chlorine to balance it out. So this is your balance equation. Next up, we are going to make the ice diagram. So we have initial, change, and equilibrium. Alright, so now we are looking at the pressure. So initially, it contains 2.5 atm of PCl5. So initially, there's no chlorine gas and there's no PCl3. And then it states here that at equilibrium, the pressure of chlorine is actually equivalent to 0.7 atm. Alright, so I don't want you to get confused, so we will erase this first so that we can see. So we are going to complete this ice diagram. So initially there's only 1 mole of PCl5, so here we need to minus X, so this one will be positive X and positive X, therefore it will be 2.5 minus X, X and X. So we get back to this value. We can say that the value of X is actually equivalent to 0.70 because it stays here at equilibrium. The pressure of chlorine at equilibrium is actually equivalent to 0.7. So, since we know that X is equivalent to 0.7, so what we are going to do now is we are going to calculate what is the value for this. So 2.5 minus 0.7, you should get equivalent to 1.8. So in other words, we can say that at equilibrium, this one PCl5 will be 1.8, this one will be 0.7, and PCl3 will be 0.7 as well. So since we already know the partial pressure of each component, we can naturally find what is the Kp for this reaction. Alright, so now we can calculate the Kp. So Kp is whatever in the product, which is the partial pressure for PCl3 times the partial pressure of Cl2 divided by the partial pressure of PCl5. So we're just going to plug in the value. So 0.7 times 0.7 divided by 1.8. So therefore, you are going to get the Kp for this reaction is equivalent to 0.2722. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.